In part 3 of our lesson on finding trig values using a calculator, you will learn how to use a calculator to solve for a non-acute angle. Let's take a look at this first example, where we have to find all values of theta if theta is in the interval 0 to 360 degrees and has the given function value. In this case, we see that the sine of theta is 0.37294. Now, because we're solving on the interval from 0 to 360 degrees, that means theta could live in any of the 4 quadrants. Okay, step 1. Determine the quadrants of theta based on the trig function value and the positive or negative sign. So we have to first consider, where is sine of theta a positive number, because 0.37294 is positive. Step 2 says draw a diagram indicating the possible locations for theta. Now we know when sine of theta is positive, that means theta could live in quadrant 1 or quadrant 2. So we know that there are 2 possible angles. Step 3, we will need to find the reference angle to figure out this second angle over here. Now the first thing we need to do to the equation is to take the sine inverse of both sides. So on the left-hand side, we're going to take the sine inverse of the sine of theta, and on the right-hand side, we're going to take the sine inverse of 0.37294. Now we learned earlier that the sine inverse is the function that undoes sine of theta, and we will be left with theta on the left-hand side. To figure out the right-hand side, we will need to use our TI-30 calculators. Now the first order of business is that we need to make sure that we're in degree mode, and if it's not, hit the DRG button, and you see you have the 3 choices there. Make sure that degrees is the one that's underlined and hit enter, and now your calculator is in degree mode. To do this calculation, we will hit the second button, and then to get sine inverse, it's above the sine button, and we're going to enter 0.37294, close the parenthesis, and then hit enter. Now in this problem, we were being asked to round to the nearest degree, so our answer would round to 22 degrees. Step 4 says indicate theta r on the drawing and then use it to find the angle or angles. Now this tells us the angle here in quadrant 1, which then also tells us that the reference angle over here is also going to be 22 degrees. And to determine the angle in quadrant 2, we would do 180 degrees minus 22 degrees, and we know that would be 158 degrees. So that gives us the quadrant 2 angle. And so in this case, theta could be 22 degrees, or it could be 158 degrees. In this next example, we have to find all values of theta if theta is in the interval from 0 to 360 and has the given function value, where the cosine of theta will equal 0.659327. So step 1 is to determine the quadrants of theta based on this trig function value and its sine. So once again, we see we have cosine of theta is a positive number here. Step 2 says draw a diagram indicating all possible locations for theta. So when cosine of theta is positive, we know that means that theta could be in quadrant 1 or it could be in quadrant 4. In step 3, we have to determine theta r, the reference angle, using the given trig value and our calculator. So the first step here is to take the cosine inverse of both sides. So we'll take the cosine inverse of the cosine of theta on the left-hand side, and on the right-hand side we will take the cosine inverse of the given value, 0.659327. On the left-hand side, cosine inverse undoes cosine, and we are left with theta. Now on the right-hand side, we'll have to use our TI-30 calculators. So once again, make sure you're in degree mode. We will hit second, hit the cosine button to get the cosine inverse, and we'll enter 0.659327, and then close the parenthesis and hit enter. Now we see that we get 48.751433, etc. Whole bunch of decimal places. In this problem, we are being asked to round to the 10,000ths place. Now we know that means 4 decimal places. So if we come down here, 1, 2, 3, 4, we see that the 3 is telling the 4 to stay. So then that means our first angle here is 48.7514 degrees. And that will be our quadrant 1 angle. Now we know that gives us this reference angle here, which means this reference angle would have to be the same. So to determine our answer, which is this angle, we have to do 360 degrees minus 48.7514. And if we do that on our calculators, we've got 360 minus 48.7514. We see that that works out to be 311.2486 degrees, and that's our second possible answer for this problem. In this next example, we will find all values of theta if theta is in the interval 0 to 360 degrees and has the given function value, in this case, tangent of theta has to equal 1.48367. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Step 1 says to determine the quadrants of theta based on this trig function value and its sine. So we notice that tangent of theta is a positive number. We know that tangent is positive in quadrants 1 and 3, so we go on to step 2, where we draw a diagram indicating all the possible locations for theta. So quadrant 1 and quadrant 3. Step 3 says we have to determine the reference angle using this given trig value and our calculator. So to get at theta, we know we will have to take the tangent inverse to undo that tangent function, which means we have to do the same thing on the right-hand side. Take the tangent inverse, in this case of the 1.48367. Tangent inverse is the function that undoes the tangent function. So on the left-hand side, we will have theta. On the right-hand side, we're going to have to use our TI-30 calculators. So to evaluate, we will hit the second button. Then above the tangent is the tangent inverse, and we'll enter 1.48367. Close your parentheses and hit enter. And we see that we get theta is 56.019859, etc. In this problem, we are being asked to round to the thousandths place, so we know that that is 3 decimal places. So when we look at the 4th decimal place here, tenths, hundredths, thousandths, 10,000ths, that 8 tells the 9 to go up. Now because it's a 9, we'll have to carry over. So a way you can think about it is that the 19 is going to become a 20. So then theta would round to be 56.020 degrees. Now you need to show that 0 in the 3rd decimal place to show that you're rounding to the thousandths. Step 4 says we need to indicate theta r on our drawing. We know that the 56.020 degrees is our quadrant 1 angle, which gives us the reference angle. That must also be here in quadrant 3. So we know theta r right here is also 56.020 degrees. And to find this second angle, we will do 180 degrees plus the reference angle. So if we enter 180 plus 56.020, you see that we will get 236.02. And to show rounding to the 3rd decimal place, we'll add in that last 0. So in this problem, there are 2 solutions, 56.020 and 236.020 degrees.